push that rock here with some math. We want to talk about the results of the mantra theorem. The mantra theorem tells us we multiply complex numbers by multiplying the moduli and adding the arguments. So say it like a mantra. Multiply the moduli and add the arguments. But what happens when we do that? So here we have an example. We have a complex number here. Let's see, can we see that? That's going to be, blow it up a little bit, 2 plus 2i times the square root of 3. And here we have square root of 2 plus I times square root of 2. Two complex numbers. We're going to multiply them together. Of course, we could just FOIL. We could go first time first, outer time outer, last time last, inner time in. Anyway, FOIL it out. And you'll get another complex number. But the disadvantage is, first of all, that's tedious. But second of all, you're not seeing what's happening. So we use the mantra theorem instead, which requires that we convert to polar form or trigonometric form, which I've done here. This complex number in polar form has a radius of 4. Oops, got the eraser on for some reason. So the radius here is 4 units long, and it's in a 60-degree angle, and so the argument is 60 degrees, and the modulus is 4. Then I convert this blue vector, or blue complex number, to polar form as well. The radius is 2 units, so the modulus is 2. It's like the magnitude of a vector. And then the angle here is 45 degrees. So the argument is 45 and the modulus is 2, and I have it in polar form. What happens when we use the mantra theorem to multiply? We multiply the moduli and we add the arguments. But what's going on graphically? That's the question. Here's what's going on. Think of this as your primary vector, and you're going to do something to it with this other little vector. So the larger complex number here, the one with the larger modulus, we're going to treat that as our primary complex number, and or primary vector, and we're going to multiply it by this other complex number. What goes on? Well, we multiply the moduli, so the new modulus is 8. Can we see that over there? Then we add the arguments, so the new argument is 105 degrees. But what happened? Well, first of all, the modulus was 4, now it's 8. So it lengthened by a factor of this modulus. So now it's way longer. Then it rotated by how much? It's over here somewhere. It's 105 degrees. Well, it rotated by this much. We rotated it by 45 degrees. So now it looks something like this. So it's twice as long, but it rotated 45 degrees. That's the advantage of the mantra theorem. We can see graphically what the multiplication does for us. And in the next video, we're going to see how we use this understanding to get the circle chop. That is, get the roots of a complex number, which chop up a certain size circle. Math made simple. Simpson Math.